Talking about rhombi and squares. Don't you just love the word rhombi? Rhombi. I like the word rhombi. All right, so I think we got a little bit of a word problem. We got actually, we're going to find out this is a piece of a quilt. It says, Kathy is designing a quilt with blocks like the one shown. All right, well, good for Kathy. All right, if she marks the diagonals of each yellow piece, and determines that each pair of diagonals is perpendicular, can she conclude that each yellow piece is a rhombus? Well, we do know that if the diagonals of a parallelogram are perpendicular, then the object is a rhombus. But what has to happen with a parallelogram? The opposite sides have to be parallel, right? And although those yellow pieces, it kind of looks like they're probably parallel, I don't know that they're parallel. I'm told that the diagonals are perpendicular, but I don't know that the object itself is a parallelogram. Now it's quadrilateral. The yellow pieces all have four sides. I see that. So what's my conclusion here? Well, no, she can only make this conclusion if she also knows that the quadrilateral is a parallelogram. And I don't really know. See, it may look that way, but we don't go by just what things look. When we prove things, it's based on facts and definitions and postulates and theorems and such as that. And so, no, I can't really prove that this quadrilateral is a parallelogram just because the diagonals are perpendicular. Don't know if it's a parallelogram or not. If it's not a parallelogram, then it's not going to be a rhombus, even if the diagonals are perpendicular. All right, so let's go again. All right, so let's see. Kathy's designing a quilt, same quilt, with blocks like the one shown. If all four angles of the green piece, so we're talking about the green piece, if they have the same measure, and the bottom and the left sides have the same measure, can she conclude the green piece is a square? Okay, so let's see. All four of the angles have the same measure. And the bottom and the left side are congruent. Well, yes, we can conclude that this green piece is in fact a square, because if all four of the angles have the same measure, then each measure must be equal to 90 degrees, because we've got a quadrilateral. There's 360 degrees of the total degrees in the interior angles of a quadrilateral, and we got four sides because it's a quadrilateral. That means that they each have to equal 90 degrees. That's one condition that's met. Now that means what? That it is at least a rectangle, right? Okay, all four angles have the same measure. So we got that far. Now, if the opposite angles are incongruent, well, the piece is a parallelogram. Well, if all four are the same, then obviously the opposites have to be the same. They have to be congruent. So we've gone from a quadrilateral to a parallelogram. We also know it's a rectangle at least. Let's see what else. So if the measure of each is 90, then the quadrilateral has four right angles. It's a rectangle. We've already stated that. So we know it's a quadrilateral. We know it's a parallelogram. We know that it is a rectangle. And so what's the condition that would lead us to conclude that this is in fact a square? Well, remember what it said about the bottom and the left sides? It said that they were congruent. And so if we've got congruent sides, bottom and left, consecutive sides, then we know that it is a rhombus. But a rhombus doesn't have 4 right angles, which a rectangle is. And so lastly, to conclude, since it has all 4 angles are right angles, 90 degrees, and the bottom and the left sides are congruent, and if it's both a rectangle, which we proved that it is, and it's also a rhombus because of the opposite sides, not opposite sides, consecutive sides, well, shazam, this thing must be a square. Can it get much better than that?